Hello, you're welcome to yet another video. This time around, we want to examine how we can use algebra tiles to resolve quadratic equation. Better still, we want to appreciate or understand how we can use algebra tiles to find the factors of a given quadratic equation. Now to do so, we have to look at what the algebra tiles are made of. They are made of three pieces of tiles. One we have on the screen, sample we have on the screen here. The one in yellow or gold is called the x squared tile. The name comes from the product of the length and width, that is the product of x and that of x, giving us x squared. So anytime we have a shape of this form, we call it the x squared tile. The second one is called the x tile. Now the x tile has a similar length as against that of the x squared tile, but the width of it is 1. So the product of x and 1 give us x. So this type is called the x tile. You know, this one is a tile which has taken the horizontal form. It could also be vertical, like this case where we have here. In that case, the longer side will be called the x side and the shorter side will be called the 1. So the name doesn't change, it's still called the x tile. Next is the unit tile, which has both its length and width being 1. So the product of 1 and 1 is 1. So we call it 1 tile or the unit tile. To start with, we need to note that in order for one to be able to solve any quadratic equation or find the factors of any quadratic equation, there is need for us to be able to understand or know these three pieces of tiles. The most important thing to put in mind is to be able to identify the constituent tiles that makes a given quadratic equation. For example, on the assumption that you are given an equation x squared plus 5x plus 6 and you are told to find the factors. This quadratic equation, unlike any other quadratic equation, can be resolved using these algebra tiles when these tiles contained in any or this given quadratic equation is arranged to form a triangle like what we have here. So what we'll be doing is to ensure that the triangle we'll be forming contains, looking at the coefficient of x squared, we have 1 here So our triangle should contain one x tile and also contain 5 of the x tiles and contain 6 of the unit tiles. After which we can read the factors from the triangle, also from the rectangle. So let's stay glued and sit tight and watch how that unfolds. Now note that the equation we were given was of the form x squared plus 5x plus 6. Also note that we said that in order for us to be able to resolve this using the algebra tiles, there is need for us to be able to form, or first of all identify the constituent algebra tiles that are contained in the given quadratic equation. In this case, what we have here is one of the x squared tiles. We also have here 5 of the x tiles and 6 of the unit tiles. So we would need to form a rectangle that consists of all these. Now note that we have a copy or one x squared tile present here, which we can make use of. So making use of this x squared tile which is present here. Next, we need 5 of the x tiles. We can easily borrow this. Can easily borrow this one. Note that the attempt is to form a rectangle, then read the factors from the rectangle that have been formed. So with respect to the constituent um, tiles that form the equation, so this is the second x tile. As we put them along, we try to form a reasonable rectangle. Note. So we also bring the third um, x tile. Since what we have here is exhausted, we can just copy and paste more just to get others. So the fourth x tile can be here. Then the fifth x-tile can also be here. Now if you're following carefully, you realize that our rectangle is gradually forming out. Now we are left with the 6 unit tiles. The 6 unit tiles. So borrowing that idea, the 6 unit tiles. Sorry. So we need 6 unit tiles. One here, another here, another here, another here, another here, another here. Now, just like we said earlier, the attempt is to form a relatively perfect rectangle, reasonable rectangle, from which we can read our factors. Good. Now, considering the fact that what we have is reasonably acceptable as a rectangle, we can proceed by reading our factors. Now, what we do is we read from the right side to the left, or bottom up, or top bottom. Note that the edge here we have here is an x-tile. The edge we have here is an x-tile. It's an x-tile. In view of that, the edge we have here is an x-tile. Good. So the edge we have here is an x-tile. So note that we will have x here. Now note that this edge is a 1, or is a unit side, or 1. Equally, this too is 1. So definitely 1 and 1 will give us 2. So we write 2 here. Now this and this, what we do to it is to add. So what we are doing is to find the sum of the constituent tile size. Good. So this side is an x tile, and this side, remember we said, is 1, and this 2 is also 1. So giving us 2. Note that when you come to this side too, we are also getting an x side. Also counting the one side, we have 1, 2, 3. So we write 3. Then we find their sum. Now this implies that the factors that makes up the quadratic equation x squared plus 5x plus 6 is x plus 2 and x plus 3.